students, coming to the next topic in the subject DAA is backtracking. So let us see the backtracking general method here. So this backtracking is mainly used to solve the problems in which a sequence of objects is chosen from a specified set so that the sequence satisfies some criteria. Backtracking, the name itself is saying we are going back. A backtracking, coming forward and checking the condition, and if it is not satisfied, again we are going back and take another series. So we are just checking the conditions. So it is, and let me write this, it is used, this backtracking is used to solve problems in which a sequence of objects, so let us take the sequence of objects is chosen from a specified set, so that the sequence satisfies some criteria, so that the sequence satisfy some criteria. That is about the backtracking. So when we use this backtracking, there is a sequence of decisions you have to take. When you are taking the problem, to solve that problem, you have to take a sequence of decisions to be made from a number of available choices. So let me say, when we use this backtracking, as a number of, suppose different choices will be there, different choices or number of choices will be there. So in this number of choices, we have to select, we have to take a decision. So there is a sequence of decisions to be made from number of available different choices, where a sufficient information is not available on the best choice. Suppose a sufficient information is not available on best choice. Okay, so in that cases, if you didn't get the sufficient information on that best choice, again you just do the backtracking, or each decision leads to a new set of choice. Each decision, so whatever the decision you are taking leads to new set of choices. Again we have to select the choice. When we are reaching one particular decision, again this decision is leading to another different choices. In that choices also we have to be select whether we get the optimal solution or not. And some sequence of choices may be solution to your problem. Okay, so then how we will use this backtracking? A backtracking is a systematic method. You just call it as a systematic method of trying out various sequences of decisions until you find out the whatever that works, until you find out that works. In that case, you like that you will use a backtracking. So backtracking means just simply whenever you are leading to find out some problem. So in some cases you are having a sequence of objects we have to be chosen from a specified set of sequences. So in that we have to check criteria. Based on the criteria, you are just selecting the best path. If you didn't get your solution, again you go back and again check for and take the another sequence of decision and again check forward. So in that also, if you didn't find the solution, again go back and take another decision and check whether there is a check the sequence of choices in that decision and find until you reach your solution. That is a backtracking, going back, that's it. So let me explain. Like suppose if you start from this position, and the start a node is there. Okay, so this is a start node. From this you are going to check for here, but this is your not solution. Again you are checking, but it leads to a dead end. Here finally there is no node, so this is a dead end. So what you will do, again you come backtrack. Suppose here is another path is there. Okay, so this is also a dead end. What you will do, again you come back. Okay, again you come to your starting node. So here you will check another decision route is there or not. So here one more path is there, so you are checking here, you are going this side. Okay, so this is not your solution. Again you are going here, but it leads to a dead end. So backtrack. This is already it's not your solution. So again you come back. Okay, and check another path is there or not. Yeah, it's another path is there. Okay, you're going here. So from here you're checking this side. This leads to a dead end. So you didn't find your solution. So come back and check here the path is there or not. Suppose if it is path is there. Okay, so finally suppose this is a node which is a success node. Means you reached your destination. Okay, so a sequence of decisions, you are going from this and this by checking everything. If you didn't find the solution, you are coming back. That is a backtracking. So this node you call it as a success node, and this you call it as a E node, so which leads to a success. E node which leads to a success, and these nodes you call it as a dead ends, because it doesn't provide a solution to your path. Means this you call it as a dead ends. Okay, let me so this is a dead end, a node which further there is no nodes, that you call it as a dead ends. Suppose these you call it as a live nodes. These are live nodes. Let me write. So these are live nodes, and this you call it as a E node, and this is a success node. This you call it as a success node, and this is a dead node. Okay, so these are the just terms related to the backtracking. I'm just explaining these nodes. So live node is nothing but a node which can be generated, okay, which can be further generated, and all of its children have not yet been generated. Means they are not yet being generated. So this is a way to go to next node. Okay, so you are going like that. And coming to E node. E node is nothing but it is a live node whose children are being generated. The live node children are being generated, and that becomes a successor. So that node you call it as a E node. And coming to the dead node. Dead node means node which is not to be expanded further. So further you can't expand that node, so that becomes the end of that tree. So that node you call it as a dead node. So here many problems. So whatever the problem you are taking in the algorithms, so many problems can be solved by using backtracking requirements, and all solutions satisfy a complex set of constraints. So whatever the problem you are taking, that problems can be solved by taking all solutions which satisfies a complex set of constraints. So those constraints you call as two types of constraints will be there. Two type of constraints are present in backtracking. So those are implicit constraint, explicit constraint. So these are the two constraints that are used in the backtracking. So implicit constraint is a rules that specifies how each element in a tuple should be related, whereas explicitly is saying that rules that restrict each element to be chosen from a given set. Okay. So the different applications that are present in backtracking is applications. The applications of backtracking are, what are the applications? N-queen problem, Next, sum of subsets, graph coloring, and Hamilton. Okay. So these are the 4 applications that are that uses the backtracking technique. So let us discuss one by one each application one by one with an example and an algorithm in the coming videos. Thank you.